Welcome to qnawire.
So in this problem, uh, we have been asked to calculate the energy of the laser pulse used in the eye surgery and the number of photons that each pulse has. So we have been given a laser with which is 23 millisecond long. So let's call that delta t. Sorry, so delta t is 23 millisecond, so it's basically 23 times 10 to the power minus 3 seconds. And the power of this pulse is 0.63 watts. So the energy in the pulse is just power of the pulse times the duration of the pulse. So we have power times delta t, so 0.63 watts times 23 times 10 to the power minus 3 seconds. So this gives us energy as 0.01449 joules. Now each photon, so let's calculate the energy of one photon. Let's call that one photon, so which is h nu or hf, which is just hc over lambda. And we have been given the wavelength of the photons are 640 nanometer. So, so in order to calculate the number of photons, let's call that value n. We just divide the energy of the pulse divided by energy of a single photon. So we have here 0.01449 joules over hc over lambda. So the number of photons in that pulse are 0.01449 times the wavelength is 640 times 10 to the power minus 9, sorry, minus 9, not 19, divided by h is 6.63 times 10 to the power minus 34 joules second. So here we have meters, here we have, let me just write the unit for energy, joules. So this is J times C, which is 3 times 10 to the power 8 meters per second. So meter cancels, second cancels, and joules cancel. So we have a dimensionless quantity, which it should be, uh, because since it's just a number, so we have the number of photons are 4.7 times 10 to the power 16 photons in that pulse.